What if you accidentally fell into a black hole? What kind of shocking sights would you see? The truth might completely overturn your understanding. In fact, a black hole isn't actually black, and it isn't even a hole. According to Einstein's general relativity, a black hole is a celestial body. Its space-time curvature is so intense that not even light can escape. Now, let's board a spaceship. We are heading toward a black hole on a journey of wonder. As we approach, we leap out of the cabin. Gravity begins to pull us in, but first, we must wear a special spacesuit. Why? Because the mass of a black hole is immense. Its gravity is equivalent to millions of suns. It captures all surrounding stars and matter. This forms a massive, thick plasma accretion disk. More terrifyingly, this disk spins near the speed of light. Constant friction heats the surface to hundreds of millions of degrees. It also emits intense, lethal radiation. Without that suit, you would vaporize instantly. Interestingly, if you filtered out everything except visible light, the disk would look different. It would glow with a high-energy blue hue. NASA's famous black hole photos show a bright orange. But that is just a representation. It is not the true color in the visible spectrum. This explains why ultra-hot stars glow with an eerie blue light. It gets stranger. One side of the accretion disk looks brighter than the other. This is due to the extreme speed of the matter. The right side is rushing toward us at high velocity. This causes light waves to pile up. It looks brighter. The left side is moving away. The light waves are stretched out. It looks dimmer. This is the magical Doppler effect. Look closely, you will see the back of the disk looks warped. It looks like it is folded over the black hole. This is not a physical fold. The gravity is so strong that it bends light. This is gravitational lensing. When we look in one direction, the actual object is much lower than it appears. Meanwhile, the starlight ahead turns blue. The black hole's gravity warps time. Time near us moves slower than time for distant stars. From our perspective, the starlight is speeding up. This creates a blue shift phenomenon. As we get closer, we see a strange aberration of light. It looks like the black hole is moving away from us. Even though we receive light from all directions, the field of view in front of us begins to shrink. We are now accelerating toward the abyss. As our speed increases, the light in front becomes blindingly bright. The light behind us struggles to keep up. It grows dimmer. This is another result of the Doppler effect. If you look back at your ship in orbit, you will notice something strange. The ship's clock is ticking much slower than before. Every signal sent by the ship takes longer and longer to reach you. Then, we pass through the accretion disk. In an instant, the disk fades from view. At this distance, matter can no longer orbit stably. Everything begins to spiral inward. About 2 minutes later, we reach the photon sphere. In this region, any light from the outside is doomed to fall in. As we sink deeper, the people on the ship see our image fade. We slow down in their eyes until we vanish. A few seconds later, we cross the photon sphere. We have reached the event horizon. From this moment on, the outside world becomes our past. We are no longer connected to this universe. Even if you send a signal, it can never escape. So, what do you see once you cross over? Surprisingly, you can still see light from the universe. You might even see your spaceship. You wouldn't even realize you've crossed the horizon. On a large scale, gravity isolates the interior. But locally, space-time feels almost flat. The curvature isn't immediately obvious. You wouldn't feel the warp of space-time yet. Because of the strange light aberration, it isn't pitch black. Instead, the black hole's shadow only takes up about 15% of your front view. You can still see a sky full of stars around it. But then, things accelerate. You fall toward the center faster and faster. The light behind you seems to shrink into your forward vision. Your forward field of view narrows. Your rear field of view expands. The distant spaceship actually looks like it's getting larger, even as you fall away from it. The moment you reach the center, everything changes. You will feel an unbelievable force tearing at your body. In your final moment of consciousness, you will feel like you are falling onto a dark, flat surface. In the next 0.1 seconds, your body and mind are shattered. You become part of the black hole's core. For you, the journey is over. But for the crew on the ship, your image is frozen forever at the horizon. Modern physics still cannot fully explain what happens inside. Current theory says the center is a singularity. It is a point of infinite curvature. However, some scientists doubt it actually exists. Perhaps we need to unify gravity and quantum mechanics to solve the ultimate mystery